So this is a video about projections, how to deal with projections, uh, you know, basic stuff, but can be useful even for people who knows already, or like fundamentals, but uh, can be interesting. So I just built a very simple setup here. Cylinder here, cube, part for the ground, like the floor, merge geo, take a lens, a scene, and a camera. All right. So first you switch here, you switch the camera. If you go to default, you can move around. You can remember this. So if I go back to this and go back to default, you remember where you. It's quite useful stuff. You can leave it somewhere here if you wanna have a look at something. To the camera. All right. Go back to default. You remember. So if you want to make a camera random view, like say you want to make this right here, go here, create camera, classic, and all the classic stuff for now. Then when you go to this and switch the camera, it will be camera you just made. If you control click here, you will change the camera. For now it's like this. If you default, let's make default this camera. Boom, goes back to that. The basic stuff. Let's stick some constant colors to objects. How projection works. There's a lot of videos about this and online, as it's a interesting subject. Okay, so now we have all colorful stuff. Jump out of the default camera, so call the colored ink. But if you want to differentiate the ground, so this is you collect all the stuff, and I always advise you use the merge geo, so you keep things organized. So these are like 3 geometries. The card is different position more to the right because it's the ground. Visually easy to see. The camera, it's a circle node, just like the scene node. You can change the color if you want to have a spot camera, great. But I always use this guy to keep it organized. So how the projection works? See the camera. So the projection works from a camera. So it will take the image the camera is seeing, camera like this image here, the camera, let's see, 5. This image, and use the same camera to project it back like a projector. So wait. Right. So if you have a camera here, like we do have there, okay, and then we have the object here, circle, a sphere, whatever. So you take a photo of this image the camera is seeing, becomes like a 2D image, and then you can take this image and stick it back to a projector, which is exactly the same camera in the same place, project it back. Yeah. Very basic concept. By doing this, you can, by understanding how this works, can do a lot of stuff. Like, for example, you want to do a cleanup, can I don't know, you're gonna do a cleanup, you can make a projection, do the projection, make a UV projection where you see the projection and 2D space, do the cleanup and project it back, for example. Let's do something like this. Render out the image here, this scanline, render, scene, to get the format of the project out. This is the image, the scene. Okay, I just speed this up a little bit because I touched on this on a lot of tutorials already. So this is just using light and trying to make the shot have more elements like shadows and stuff. So you guys can see that this actually will not change, like the complexity of this, of what we have, will not change anything. It can be very simple or extremely complex. So that's why I'm making this section a bit faster to jump to a position where I found the light to be working nicely. Okay, so you have this image. If you take this image and frame hold this image, you get the same camera. Frame hold the same camera to the same frame, basically. Project this image. You can also, if you want to do this to be sure, go from the same stuff, from the same, and get the geometry, the same geometry. And take a look at the inline render. It's the same. So what I did here, I jumped the light. This image, we have the light. This is making out the shadow, blah, blah, blah. And up until this point, no light. Here, there is light. I render out one frame. This I can even make like a, let's say, if we can higher quality, one frame, very nice quality. I'm gonna show some other stuff. So this is B. E. More. Right. So you're projecting this image to frame. Nice. Using project 3D, applying this material, which is a static to the image, over the same geometry. Here. Just sticks the project image there. If you look through the same camera, this is going to be exactly the same. Of course, there's no difference. We're using the same camera to project the same image. So this opens up a lot of very interesting things you can do. And then I'm gonna make a movement in this scene. Yeah. Complicate things. Great. Frame number 1 here. That me one. Click a little bit. First frame. Right. This movement. Great. But if I take the animation, so I'm freezing the frame. First one, 1001. Making paint. Also freezing again. I'm gonna project this on top of the geometry and use the same moving camera to have it move. So what's going on here is that I'm shooting, I'm animating this camera, freezing a projection. The camera keeps moving. So what I have here, the result, I compare here. The difference will be minor edge, but this is because of anti-aliasing and the painting stuff. That tells us that if we have CG animation happening here, okay, we have a animation like this, and we get the camera holding the plate. A good solution to project change you need to do, like on the image, by freezing the frame, making the whatever paint you need to do, projecting it back on the texture. And if you have this pre-rendered here, we've escaped the heavy light. I have to render this stuff again. You just render the stuff out, and even render only the alpha if you want. Great. So you have here an alpha solution for this, which is tracked through the scene. And you can stick that on top of the top of your original render. That opens up a lot of possibilities. One other thing that you can also use that to render out from a slightly different camera. This will also work in a bunch of situations. But anyways, so this is number one. What we can see here, that what we have is the geometry, original geometry. I'm looking at this thing. Then we have just the stuff being projected. Look here, there's the clean geometry, the projection. You have the projection flying, sticking on the geometry. Then we render it out with alpha, stick it on top of this. So this opens up a lot of possibilities, which is, for example, let me put thing to the side, which is to have access to all the information a 3D scene will give you. Which I rendered in wrong path now. So one very cool thing we can do a 3D scene like this is to have a position to pass. This will be a representation of the position pass. This little guy here. Okay, that tells Nuke where the objects are in space. And if you combine this, a projection, or how it works here, have something like this, which is I'm projecting the image back, but respecting its 3D position, because we know via this pass here, position pass, that we can have from the surface point, from the vectors, the scalar render, we know where each point should be. This opens up this kind of possibility. What you can do with this stuff. And for example, if you don't have access to the geometry, let's you get just the render. And you stick a scene here. But this now it's a position data. Take a geometry minus slab this section. So you can stick a geometry where you need, really where you need. So let's say client is asking you to stick something inside of a monster's mouth, like a dust or a spark or whatever to the element or something like this, and really go there and put it where it should be. In this case, I'm just gonna make a little card. Okay. I'll paste it. Facing camera. You know the camera is on this place. Because if I take this, stick the camera here, and see the camera is from point. So this node is actually doing what we did here. Project the same image on top of the geometry, but this node doesn't have access to geometry anymore. This is a 2D image here, right? So we are using the position data, but the result. What we are doing here, I'll try to paste the right, great. Then another scanline render here. Okay. Same the same format. Let's hide this guy. I'll just have your card there. We don't have anything on the card, so let's paint something here. Great. Take a constant. Right. Okay. I'll have this right. Stick it. Great. So we know that it is indeed behind the stuff, the place you decided to put, right? Say you wanted to right here. Who knows? Camera. Say this right. One. Correct. Interesting. Right. So I have this now. with this, you know it's in the right place. This guy. Uh, I'm not gonna actually care because otherwise I'll be forced to. Now, so now we know it's where it should be, where we want it to be. So we have, for now, we have a clean projection, just the paint stuff, over the original image. Now we also produce this guy. Also should be behind the correct image, but respecting the 3D position, so moving properly the camera. So let's see if we can do this. Messy, bear with me. This is the input. This is our image, which is the 3D render of this. Let's have the movement. And this is our behind this little guy. Let's see if off of it. We can easily hide in this. What kind of pass we can do ourselves to. Yeah. And to just make a key. Time. Great. Practice. Time. What I want to show you guys is that you can actually just more about the positioning. So what we did here, which is we stick something in 3D space without changing, without having access to the geometries. If this was a 2D render with a position pass, we use the points, the position points, to generate projection of the image over the position of the points that should be in space. Basically what we did here. By doing that, we could have like a proper representation of the 3D space. And we were able to position a card behind the object that we want, this red stuff, render out, and know that it's not sliding. I don't care about the alpha, that we don't have like a nice alpha of the blue ball now. We can also do that, but that's not the point. I want to show that by not trying to trick yourself into sticking something and tracking something, that you can use the position to points to see how the 3D space is actually working. So you can stick your stuff in the right, correct position. So it will always follow the right movement. So this is one of the cool stuff we can do with production of projection. This opens a lot of options. So this is also happening here. All the parallax changes we see objects are all also correct. If we come back here and make a little paint on this side here, really different perspective. Follow me here. Very edge, it doesn't matter because it's all projected onto, in this case, onto the same geometry. So the result will always match perspective changes, whatever. Always will. So get used to this kind of stuff, get familiar with this kind of tool, and understand how this is happening, what's happening here. It's a great way of training our heads, and from this you can extrapolate a lot of cool stuff. So, for example, this can be a cleanup. You have a camera projection. This can very well be a cleanup. In this case, you're not even doing a UV projection. We can also speak on the next video about this. Yeah. So one of the all the benefits of using this to position the card, whatever you have, that you can actually use the same. And instead of rendering this heavy motion blur here, and use the motion blur 3D. Just use the camera. It will also give you proper blur. This case the movement is so small that I don't even see. Try to blur here. This by itself will be faster than the movement barely visible. But this will be much faster. Even if I hold the shot and then. But on fast moving things, you can use a 3D motion blur or the normal motion blur, and it will give you very good results. Instead of tracking stuff, masking stuff. Yeah. So just a quick recap of how this actually works. The whole concept is that the camera cinema camera, it sees the image of your scene, of your object there, whatever you have. It sees this, and then when you render, it will give you a 2D flat image that the camera is seeing here. Camera field of view. Take flat image. See here things you have there, blah blah blah. Great. So this image you can also have carry a position pass, normals pass, a lot of other pass. For this, have this. So the position pass records the 3D coordinates x, y, and z of every single point the image. So in the 2D image, this little point here, color, this little point here is the same as this little point here. Because of the Nuke knows this point carries this localization, XYZ. It carries this localization. And then the position to points to do what? We project, we'll take, to make a projection represent the things you have by projecting each pixel on its correct 3D localization YZ. So it will give you a representation of the scene like this. And this can be extremely complex. Doesn't matter. What happens is you can when you stick something behind something, next to something, you can actually put it in the right position. You have to animate it. The objects on the scene are static. The camera is animated. If you have a object that is moving, uh, you can also have this animated, and this will change per frame. But anyways, to simplify life now, this will give this visualization. With this stuff, you can stick things the correct 3D position placement. Render this guy out, and you can be 100% sure that when you merge it over or under or whatever your actual scene, you don't have to worry about this. But if it's sliding or not, because it will not. This gives you a lot of headspace. Very good to understand how to use. We had a show that we need to put a lot of snow everywhere on the ground, and without being comfortable that 3D position of things, we didn't have the geometries. We have like lidars, and but we have position passes for the renders. So without this, would not 100% not position the snow on the right place. So in 3D space, camera was moving sideways. So camera was doing all kinds of movement, but the worst one you want it is. So things are moving that way very fast. Is in the screen. The camera is moving that way, that way. So the objects move like this, and you can't be sure they are in the right place. I'm trying to mimic this in real. Just change the animations. I also can go to camera 3. Okay. Not this. So camera 3. Great, let's animate this guy. Plum, plum. Last frame. Click. Something like this. Not animating. I'm not looking at the camera, geez. First, manage this close. Okay, this. Do this. Time. Slightly to right. Go back. Do more. Okay. Great. Bye. Now, right. This is the worst case scenario. Because if you need to add something, let's say we need to add this little guy, much smaller. See the drama. So we need to add a little one here. Then let's have another one. This properly. There is a nice trick if you have several cards. I'm gonna and this every node. Select all of them. Merge. View. Whatever, it will stick them all together for you. Card. But slightly behind. This was the nasty stuff. This card. Yeah, cool. Also, the camera needs to be great. So, line card filed. See, this is you. Weight of points, tiny little position point. So it's not actually geometry. Just putting points where they should be in 3D space and uh, projecting the RGB of this specific point on itself. So if you know the distance, like it's the geometry, but it's not. Guy, 02 axis. Great. So uh, form easy to see. All in this same instance. Also all this. Closer to the camera. Guy here. Something. Little guy. Nice. Right. See how this one moves slightly faster than the other ones because it's closer to the camera, right? This. So by doing this, by having a visual representation of the, even stick a guy way behind it. Card. Let's see better. Uh, so this is exactly the best example for this. It's, you know, when you position it in the right place, can be you have a LiDAR, or if you have the CG itself. If you don't have a CG, but if you have a LiDAR, and these two positions start in the right place, you don't have the LiDAR and you have the camera, you can also use the camera to make yourself the position to points. We will project the image itself. It's pretty cool, and then you can 100% for sure stick the stuff in the right place, even if it's like this. You'll be there for just a couple of frames. 100% sure it's correct. That is excellent. So I'm gonna stop recording now because I'm gonna bring footage that I have the camera already tracked. I'll show you how this an actual. Okay, so this is from another ongoing tutorial. So this is the image. And I'm gonna use what I did is I just made it easy to track by making it a bit darker. I have the scene here, right? I'm gonna be normal as well, but I'm gonna make a geometry for this. Let's see. Points. Uh, we don't have enough density here. But if I not cloud generator, source, see, because this will work, but I did not have a lot of points on this track. Will not generate a lot of uh, position points for us. I'm trying to make a geometry. So by using the geometry, then yes, open to it. There. So see, this is exactly the same stuff. It's already projecting the texture on showing us the texture of each point. That one flying crazy guy here. Look. All right, great. So let's change to stuff. Vertex selection. Yep. Oops. Oop. So now we have a mesh, and this should give us a lot of points to work with. On here. So I have this. I can project. If I want to have the, because there's no texture here, right? So for what if I want, I can project. Uh, Same camera. See? So now I can do as I said with a normal footage. This is not a CG render at all. This is just me around with my camera in the garden. Showing 2 points. But it's not geometry, like you guys can see. It's a giant amount of points. All the position information, the geometry we generated, the mesh gave us. See? So I have this. I'm gonna take a card here. Same stuff. Something. See? Here is different. Let's change it. Right, let's move the card and put it in whatever place. Want. Great. Where is the camera so I can see where it's pointing? Nice. More. Right, great. Okay. So now we don't need this guy anymore. Render this guy out. I'll use the same. Which one is same. That it was a 3D tracking camera I did. Okay. Great. And now we can confidently do this. Take this guy over the phone. And take this guy. Y. That's there. And you can confidently play, and it will be sticking to the phone. So if we have a very specific position to put stuff, like if they say I want it really, really touching the wall, the geometry is very wild because there's like a box here. I'm gonna put it on the wall itself. Okay. It's I can hide this now. It's sticking there. And now that we found the line of the wall, even if we don't have the whole geometry, we can just move it on this axis. So the position to points is extremely useful stuff for CG renders, like we simulated like a CG render, or for actual normal footage. Will make your life easier when you have to put stuff the correct depth. So if you would eventually add more CG over this, the focus it, the position of the stuff be all correct. Both should also be correct. Hope you guys enjoyed this one, and I will go back to working on the other one as well. But this is something that, to me, I see people not using all the powerful options we have with projections.